Hello, check. All right, people, I believe we are finally live. Thank you so much for joining into the session. I hope I am audible and visible. If you can see me, if you can hear me, please write you in the chat box. You know the drill, yes? All right, so today we are gathered here to revise physical chemistry for your exam that is tomorrow, yeah? So without any further delay, let's get into the first question of the day. So what we'll do is we'll revise all the concepts of physical chemistry that are important for you via questions. In the middle of these questions, I will also derive the expressions for you that are necessary for you. I will also tell you about the formulae that you might need to remember, and we'll also look at the excerpts from the NCERT. Yes? Alright. So, this is the first question that we have for the class. Calculate the overall order of the reaction which has the following rate expression. Yeah? So, my dear friends, what would be the order? Order is equal to the sum of the powers of these concentrations. Yes. So, it's very simple over here. Half plus 3 by 2. Very difficult calculation, people. Yeah. So, whenever your rate equation looks like this, A times X, B times Y, C times Z, your order of the reaction is equal to X plus Y plus Z. So just the sum of the powers is known as the order of the reaction. Perfect. Now, these two questions are really interesting. First of all, you should also try to answer this in the chat box. What is the effect of temperature on the rate of a reaction? What do you think? If I increase the temperature, will the rate increase or will the rate decrease? What is the effect of temperature on the rate of the reaction? All right. So, my dear friends, if I increase the temperature, if the temperature goes up, the rate of the reaction will always increase. With the increase of temperature, the rate of the reaction always increases. Okay. If you decrease the temperature, rate will definitely decrease. Temperature low, that means the rate of the reaction will become lesser. Now, why does this happen? Does anyone remember why does this happen? Maxwell-Boltzmann distribution. If you don't remember, I will explain this idea to you. But before we get into the explanation of that, can we define what is meant by the rate of a reaction? What do we mean by the rate of a reaction? Yes, rate means, in very simple layman terms, yeah, in very simple layman terms, rate is basically speed. Yeah. But now you must be wondering, sir, shouldn't we use some fancy words to describe the rate of the reaction, especially in the board examination? Yeah. I'm sure you must be wondering, speed sounds very so shouldn't we have some better definition for the rate of the reaction? You might write it as the rate of change of products or rate of change of amounts of reactants. You can write it like that. Yeah, rate of change of amount of reactants, rate of change of amount of products. But let me show you one thing from the NCERT. Okay, and once you read that statement, I am sure you will have a smile on your face. So give me a moment. I'll display the NCERT on your screen for this chapter. So when these guys have very eloquently defined the rate of the reaction, have a look. Look at this paragraph. You must be knowing that the speed of an automobile is expressed in terms of change in the position or distance covered by it in a certain period of time. Similarly, the speed of a reaction or the rate of a reaction can be defined as the change in concentration of a reactant or product in time. So even they have given the example of speed. And at the end of that example, they've mentioned that it can be defined as the change in concentration of the reactant or product with respect to time. So if you write something like this, you will get full marks in the board exam. Okay. And anyway, if we go back to the question, it's a 4-mark question with every point having one mark. It could come as a 4-mark question with every point having 1 mark, or could come as a 5-mark question where the first 3 points have 1 mark and the last point has 2 marks. Okay, so that is something that it can come like. The speed of the reaction, very nice. Okay, so before we solve this numerical question, let me remind you of the Maxwell-Boltzmann's distribution. Yes, do you remember the graph of this one? The graph, if I draw, will look something like this. Yeah, remember? The graph will look something like this. Okay, so now my dear friends, what is on the x-axis of the graph? What is on the y-axis of the graph? X-axis and y-axis, what is there? Do you remember? Yes, Sai Charan, these are all board previous year questions, okay? See, we have 3 chapters to cover and you can assume approximately 1.5 hours for each chapter. So, 4.5 hours total should be the duration of the class. Yeah, people, do you remember what is there on the x-axis and the y-axis of that Maxwell-Boltzmann distribution? One of those is energy and the other is the fraction of the reactants. Yes, so let me see where they've mentioned this graph in the NCERT. Hopefully they have. Should be near Arrhenius theory. There we go. So this one is known as the Maxwell-Boltzmann's distribution. On the y-axis, as you can see, we have the number of molecules or fraction of molecules, or you can also say percentage of molecules. Our brain understands things better when we say percentage, right? So percentage of molecules on the y-axis, and on the x-axis we have the energy of those molecules. You could define it as the kinetic energy. Fine. So, where did it go? Energy, and I can say percentage of molecules. Now, do you understand what is activation energy? Do you remember what is the meaning behind activation energy? Activation energy is the minimum amount of energy required for a reaction to happen. Yeah. Activation energy is the minimum amount of energy that you need for the reaction to start. Okay. So let us say the activation energy of this reaction is this much. That this is the minimum energy required for the reaction. Activation energy. Can you see how many molecules out of the total molecules have the energy to do the reaction? This is the total number of molecules. The area under the curve is total number of molecules. Only this many molecules have the energy to do the reaction. Very small number of molecules have the energy to do the reaction. Now, what if I increase the temperature? Let us say I increase the temperature. If I increase the temperature, the graph will change. The graph now starts looking like this. So, if this graph is at temperature T1 and if this graph is at temperature T2, you should know that T2 is greater than T1. So, at higher temperature, the graph becomes a little flatter, but now realize, at higher temperature, there are more molecules with more activation energy. Yeah, there are more molecules with energy more than activation energy. So now, in the second picture, these many molecules can do the reaction. So, when temperature increases, number of molecules that already have activation energy increases. Okay, so when temperature increases, number of molecules that already have this energy also increases. So if the number of molecules with enough energy is more, speed of the reaction will be more. Yeah, so speed of the reaction will be high. So now I hope you understand why the temperature increases rate of reaction. Why increase in temperature implies an increase in the rate of the reaction? Because the number of molecules having that energy also increases, right? And yeah, fine. Cool. So the explanation that I've given over here on this particular page, we will use this in other questions also. So wait for those questions, but before that, let's solve this particular question. A first order reaction takes 77.78 minutes for 50% completion. Half-life is given to you. 50% completion means half-life. Okay. Calculate the time required for 30% completion of this reaction. My dear friends, please tell me yes or no. Do you remember the first order reaction formulae? Do you remember those formula? Vignesh should be, man. I've gone into a lot of detail. Do you remember this? Some of you do. Some of you maybe don't. Yeah. So let's do one thing. Let us define, or I should say derive, the expressions of the first order reactions. Okay. Let us derive the entire thing about the first order reactions. It will be helpful for board examination, also for your JEE examination. And when we do it together, you will realize it is so simple. You can literally derive it in 2 minutes. What do we mean by first order reaction? Let us say our reactant A is going towards product P. I can define the rate of the reaction as minus dA by dt is equal to K times concentration of A raised to the power 1. First order means order is 1. So power of the coefficient is, power of the concentration is 1. Why did I write minus sign over here? Because the amount of A is going down. A is the reactant, so the reactant is decreasing, therefore we put a minus sign over here. Okay. Now if I rearrange this, just a little bit of rearrange, I can write dA by A is equal to minus K dt, where K is the rate constant of the reaction. Now time has to be integrated from 0 to t, and A has to be integrated from A initial to A final. What is A initial? Initial amount of reactant. What is A final? Final amount of reactant. Okay. So now once we do the integration, people, the right hand side of this integration is very simple. This will become minus K into T. Okay. What will happen to the left side? The left side is basically 1 by x. Integral 1 by x is ln of x. Yes. So we will put ln of, need more space to write it down, ln of A final minus ln of A initial. Yeah. Ln A final minus ln A initial. People, do you remember the properties of log? Ln x minus ln y is equal to ln x by y. So this can be written as ln of A final upon A initial is equal to minus kt. Done, people. Derived. Derivation is done. Now, let us try to calculate half-life. What do we mean by half-life? Half-life is equal to the time when the final amount of A is half the initial amount of A. When the reactant is half over, that is what we define as half-life. We'll call it T1 by 2, T half. So now at this time, let's put the values. For T half, let us put the value. So I can write ln of A initial by 2 upon A initial. A final is put as A initial by 2. This is equal to minus K T half. Yes. So now I can write this A initial by A initial is cancelled. Ln of half is equal to minus K T half. If I put the minus sign in log, you will have inverse. Do you realize that A ln x is equal to ln of x to the power A? Do Do you remember these properties? So I am taking the -1 on the left side and then putting it inside the log. So then I can write ln of 2 is equal to k into t half. So half-life value for first order reaction is equal to ln of 2 by k, which can be written as 0.693 by k. Now let me remind you that this ln function is different from log function. Okay, ln of x is equal to 2.303 log of x. Yeah, ln is the log to the base of e, Euler's constant, natural log. This log is to the base of 10. Okay, fine. So Parth is asking, will they ask derivations too, sir? They might. They might. They might ask it in one or two mark question also, just to write this formula directly. Sometimes they can ask derivations in 5 mark questions. So if you know this, it's very simple. And it's just a mathematical manipulation. It's not that complicated either. Yeah. Cool. So now we have derived all ideas about the first order reaction. Now let us do this question. A first order reaction takes 77.78 minutes for 50% completion. So what is given over here? T half is equal to 77.78 minutes. So can I say K is equal to 0.693 divided by 77.78 minutes? I can say this, right? T half is equal to ln 2 by k. Use that formula over here. K is equal to ln 2 by T half. Very nice. So now we have the rate constant of this particular reaction. We'll do the calculation later. Now, calculate the time required for 30% completion of the reaction. At 30% completion, okay, what's the reaction? A going towards products. At 30% completion, so A initial is A initial, but at 30% completion, what will be the A final? What will be the amount of reactant remaining? A final is equal to 70% of A initial. People, do you understand this point? Yes or no? Please tell in the chat. Fine. So A final will be 70% of A initial because 30% is gone, so 70% is remaining, right? So now people, can we use the formula ln of A final upon A initial is equal to minus KT? Put that. So you can write ln of, just a second, ln of 0.7 A initial upon A initial. This is equal to minus, this is your K, 0.693 by 77.78 into T of 30%. Now it is just about calculation. Yeah. Now it's just about calculation. So you can cut A initial by initial over here. This is basically ln 7 minus ln 10. Yeah. Ln 0.7 can be written as ln 7 minus ln 10 because this can be written as 7 by 10. This is equal to minus 0.693 by 77.78 into T 30%. Can you do the calculation, please? Can you calculate what is the T of 30%? Yeah. So see, in the examination, if you write till this point, you will get 80% marks. Okay, if this question is, let's say a 2 mark question, then if you write till this point, you will get 1.5 mark. Half mark will be there for the final answer. Okay. Kichu, so understand 30% completion means 30% is gone. So what is remaining? 70%. Initially you had 100%. 30% is gone, so 70% is remaining. So final amount of reactant is 70% of the initial amount. Yeah. Answer, people. Come on. See, this is not a movie that you are watching. Huh? You have to calculate the answer also. Don't just look at the class like a movie. Have to write the answer as well. Anyone? Only Ashwin has given some answer. Hey. Nitila Darshini is saying, why aren't you taking log? You can take log over here. You can convert this into 2.303 into log, because log values are given. So basically, ln of 7 will be 2.303 into log of 7, and the value is given over here, minus 2.303 into log of 10 is 1. So let it be like that. This is equal to your minus 0.693 by 77.78 into T 30%. So some approximation that you can do is you take this as 0.7 only. If you take this as 0.7, these two will cut each other very nicely. This one you can calculate. Yeah. Okay. So this calculation, please try on your own. Please try the calculation. The answer will be somewhere around 40 minutes. Okay. The answer will be somewhere around 40 minutes. Coolio. Let's do this one now. Shall we? Identify the order of the reaction from the unit of its rate constant. People, just to explain this idea to you, what can I say? Minus dA by dt is equal to k times a to the power order. That is what I can do, right? Now, let's think about the units. Let's think about the units on both sides. On left hand side, what is this? This is dA. A is concentration. Concentration is mole per liter upon time. Right hand side, K unit, I don't know, into a to the power order. Now, let's say order is 0. If order is 0, the unit of K is mole per liter per second. So, order 0, unit of K is equal to mole per liter per second. Acha. You can try for first order reaction. Yeah. For first order reaction, you'll realize mole per liter and mole per liter get cancelled out. For first order reaction, K will be equal to 1 by second. First order, K is equal to 1 by second. Now, lastly, the answer over here, mole per liter upon time is equal to K into a to the power 2. So, basically, the unit of a to the power 2 will be mole square upon liter square. So, 1 mole per liter from here will cancel 1 mole per liter from the other side. So, I can say that K is equal to liter upon mole into time. So, this is liter mole inverse seconds inverse. Order is 2. People, what I want to say over here, it's a point that I want to make. Physical chemistry is not supposed to be memorized by formulae. You have been remembering formula all your life. Mole concept 200 formula, electrochemistry 4000 formula. That is the most rubbish way of understanding chemistry. Physical chemistry needs to be done via logic. With simple logic, we have understood that the order of this reaction is 2. There is a formula, but why do you need to remember the formula? Even if you derive this way in the board examination, you will get the marks. Okay, so that is the point of physical chemistry, that remembering formula is the wrong way to study it, because that just creates unnecessary pressure. Anyway, let's look at the next question. The conversion of molecules A to B follows second order kinetics. If the concentration of A is increased to 3 times, if the concentration of A increased to 3 times, how will it affect the rate of formation of B? What do you think, people? R is equal to Ka square. So now, if nu A is equal to 3 times A, yeah, I can say R is equal to K into 3A square, which is equal to R. Why am I writing R again and again? Yeah, this is equal to 3 square is, you know what is 3 square? 9 times Ka square. So the rate of formation of B becomes 9 times the original value. Write the expression of integrated rate equation for zero order reaction. Can we do that? Very quickly, let's derive the zeroth order also. Minus dA by dt is equal to K times A to the power 0. So I can rearrange it and write dA is equal to minus K dt, because x to the power 0 is 1. A initial to A final, this goes from 0 to T. You can write concentration of A final minus concentration of A initial is equal to minus KT. Done. Even if you derive and write, it takes like 1 minute. Cool, people. So that is also done. Simple, nice, easy. Physical chemistry is the most scoring part, because if you derive the expression properly, if you solve the numerical properly, you will get full marks. Just make sure you write all the steps, because it's board examination. Okay. This is a little bit from the Arrhenius equation. The first order reaction is 50% complete in 30 minutes at 300 Kelvin, and in 10 minutes it is at 320 Kelvin. So basically what it's saying is half-life of the reaction is given at temperature 1 and temperature 2. Half-life of the reaction is given at 2 different points. So what I can write is at 320 Kelvin, K is equal to 0.693 by 10 minutes. 10 minutes, yeah. And at 300 Kelvin, K is equal to 0.693 divided by 30 minutes. Yes, I have 2 different values of K at 2 different temperatures. Now, let's revise the Arrhenius equation. Arrhenius equation tells you about the dependence of rate constant on temperature. So Arrhenius equation says that K is equal to Arrhenius constant A into e to the power minus of activation energy by RT. So let's put these values into that expression. Fine. So let's call it K1 and let's call this K2. So K1 is equal to A into e to the power minus activation energy by R into 320, and K2 is equal to A into e to the power minus activation energy by R into 300. Yes. Now people, what we need to calculate is we need to calculate activation energy for the reaction. So what will we do? Divide these 2 statements, you got the answer. If you divide these two statements, you have the answer. But in board examination, you have to write one statement to get full mark. If you don't write this statement, they might cut half mark. Okay? So what you have to write is, assuming activation energy is constant for both temperatures. You have to assume that the activation energy does not change with temperature. This is an assumption that we have to make. So I can say this is equation 1, this is equation 2. Let us divide 1 by 2, which is equal to K1 by K2. That is equal to, Arrhenius constant will cancel. This by this, A will get cancelled. Fine. E to the power minus EA by R into 320 divided by E to the power minus EA by R into 300. My dear friends, look at how I will evaluate this expression. Do you remember, just as x to the power A upon x to the power B, I can write it as x to the power A minus B. Simple mathematics. So let's do the same mathematics over here. E to the power minus activation energy upon R into 320 plus activation energy by R into 300. Took the power upstairs with a negative sign. Now see how simple your calculation has become. What will be K1 by K2? If I see K1 by K2 is equal to 3, just divide these two things, 0.693, 0.693 cancel, you will get 1 by 10 upon 1 by 30, 30 will come upstairs. So simple. So K1 by K2, which is 3, is equal to E to the power, let's take EA by R common, into 1 by 300 minus 1 by 320. Now can you solve this mathematical equation? Can we solve this mathematical equation? You can do the logarithmic form as well. There is one question where I will use the logarithmic form. It's okay. But this is also one way in which we can easily solve. See, this is a very simple expression, no? I take ln on both sides. I can say ln of 3 is equal to EA by R into 1 by 300 minus 1 by 320. Simple. Yeah. Log 3 is given. You can use that over here. Done. Okay, so let's do it on the next page. So now ln 3 can be written as 2.303 times log of 3, and this is equal to EA by R into yes, mathematical. 320 minus 300 will be there on top. And if you want, you can cut power of 10 also. Sorry. Yeah. Now it's just about some mathematics, people. Activation energy is equal to R into 2.303 into log 3 into 30 into 320 divided by 2. Can you solve this? Log 3 is given as 0.4771. Okay. R is also given. Yeah, R is also given 8.314 joule per mole Kelvin. So the answer will come in joules. Yeah. Has anyone done the calculation? I can see 2-3 people, Rishikant and Atreya and Kevin and Sai are giving the same answer. So I assume that is the correct answer. If you want me to check, I will check. Just give me one moment, okay? Very cool. This comes out to be 43,848.5 joules, which is 43.85 kilojoules. Prajesh, yes, you can use this method. Perfect. If you do this calculation, you will get full marks. Basically, exactly like this, if you write in the board examination, you will get full. Kevin, I know, man. I wish they gave calculators, but sadly, the boomers don't believe in technology. And the boomers are the ones who set the examination still. So, till the time they inhabit this planet, I don't think things are going to change. Ghost is saying, sir, can we leave it at that in the examination? You will lose marks. So, depending on the checking person, if you don't have the final answer, they might reduce half mark, they might also reduce 1 mark. So, final answer is important. So, Rishikant is saying, will they give log table? No, they will give the value of log in the question itself. So, if they don't give log tables, they will give you the values of logs in the question. Alright. Nitila Darshini is saying, can't we use the formula? If you remember some formula, you can. Otherwise, that's exactly what we've done. We've also used Arrhenius formula only. If you take log, you will get logarithmic formula. But I personally find that working with exponential equations is easier than working with logarithmic equations. Dividing and multiplying is easier than subtracting and adding. So that's why I prefer to work with logarithmic formula. I mean, the e to the power formulas are easier. Let's do this one, people. Find the, okay, for the reaction, so find over here, for the reaction 3A going to 2B, rate of reaction is dB by dt. What is it equal to? Simple idea over here, let me tell you. If we have any reaction that looks like this, A times A plus B times B going towards C times C plus D times D, I can write for this particular equation according to stoichiometry minus 1 by A dA by dt is equal to minus 1 by B dB by dt equal to plus 1 by C d of C by dt equal to plus 1 by D of capital D by dt. Basically, I'm equating the rate of change of all of these things according to their stoichiometric coefficients. So over here, I can write minus 1 by 3 dA by dt is equal to plus 1 by 2 dB by dt. So what is the answer? Okay, so please don't do silly mistakes over here. The only thing that you can do wrong in this question is a silly mistake. Please don't do the silly mistakes, okay? So this is an application of that particular statement. A chemical reaction 2 times N2O5 going to 4 times NO2 plus O2 in gas phase was carried out in a closed vessel. The concentration of NO2 was found to increase by 5 into 10 to the power minus 3 mole per liter in 10 seconds. Calculate the rate of formation of NO2 and rate of consumption of N2O5. How do we do this, people? First of all, I can write minus 1 by 2 d of N2O5 by dt is equal to plus 1 by 4 d of NO2 by dt, which is equal to plus 1 by 1 into d of O2 by dt. Yeah. Now, over here it says that d of NO2 by dt is equal to 5 into 10 to the power minus 3 mole per liter divided by 10 seconds. So this comes out to be 5 into 10 to the power minus 4 mole per liter per second. Or just to make the units clear, you can write like this also: mole, liter inverse, seconds inverse. Okay, so writing the units is important in board exam. If you don't write the units, they will cut marks. So writing units is very important in board exam. So this is the rate of formation of NO2. 5 into 10 to the power minus 4 mole per liter per second. Okay, this is the rate of formation of NO2. Now for option B, we'll use this. So rate of consumption of N2O5. So d of N2O5 by dt is equal to minus 2 by 4 into d of NO2 by dt. So which can be written as minus 1 by 2 into that, which comes out to be 2.5 into 10 to the power minus 4 mole per liter per second. This is equal to rate of consumption of N2O5. Why did I not write minus sign over here? If you write minus sign, that is also fine. In boards, they don't care too much. But because this is rate of consumption, consumption already means it is decreasing. This word of English consumption already takes into account the negative sign. Understood? Why did I not write negative sign over here? Because the English word consumption already means it is decreasing, it is getting consumed. Okay, so if you write the minus sign, that's also fine. If you don't write the minus sign, technically speaking, it is correct. Alrighty, this is also done. Next question. So this is from the logarithmic expression of the Arrhenius equation. The rate constant for first order decomposition of N2O5 is given by that. Calculate the activation energy. So let's take the Arrhenius equation. And take log. Let's take ln on both sides. First, for e to the power something, we have to take natural log. So let me remind you of this. Ln of e to the power x is equal to x. Okay. So what I can do over here is ln of k is equal to ln of a plus ln of, sorry, I'll derive the entire thing for you. E to the power minus ea by rt. So I can write it as, second thing I'll use is ln of x is equal to 2.303 times log of x. So let's convert the ln into logarithmic form. So I can write 2.303 log of k is equal to 2.303 log of a minus ea by rt. Taken that out of the e to the power something. Now let's take 2.303 common on both sides. Divide by 2.303 on both sides. So I will get log of k is equal to log of a minus activation energy by 2.303 RT. Some people remember this formula directly. That's okay. If you remember this, fine. If you don't remember it, it's not difficult to come from here to here. Compare these two equations. Compare these two equations now. So this is given as 23.6 minus 2 into 10 to the power 4 Kelvin by T. Compare these two, you have your answer. No? Log A is this much. E by 2.303 R is 2 into 10 to the power minus 4. Done. Yeah, activation energy will come out to be 2 into 10 to the power minus 4 into 2.303 into 8.314. This will come in joules. Done. All right, people. So you can do this calculation hopefully. Plus 4, sorry. Plus 4. Okay, so that's all. So this will be somewhere around 440 something kilojoules. You can calculate. So 10 to the power 4 joules I can write as 10 kilojoules. So 20 into 2.3 into 8.3. Yeah, approximately 400. A little less than 400 kilojoule, I think. Anyway, you do the calculation yourself, not a big deal. Next question. Can you do this first part on your own, people? Can you do this on your own? After the class, can you practice this on your own? Same application, same reaction, in fact, that we did 2 pages back. Maybe the value is different. So this one, you do it on your own. Second part of this question, let us derive now. What we want to derive is a relationship between T99% versus T90%. Can we derive that relationship? For T90%, A final is equal to 10% of A initial equals to 0.1 times A initial. 10% can be written as 0.1. So I can write ln of A final by A initial, which is equal to minus KT, is equal to ln of 0.1. Yeah, I can write this. So now I have T90% is equal to ln of 0.1 by minus K. So you can manipulate this a little. How can I manipulate this? Can I simply write ln 10? If I take minus sign over here, ln of 1 by 10. Yeah. So if I take minus sign inside, this will become ln of 10. So I can write T of 90% is equal to ln of 10 by K. All right. So we can figure this out. Let's do for 99%. For T99%, A final is equal to 1% of A initial, because 99% is gone, 1% is remaining. So I can write as 0.01 times A initial. So similarly, I can write ln of 0.01 is equal to minus KT. So I can write K is equal to ln of 100 upon K. This is K 99%. Divide both things together, you got the answer. Yeah. Divide both the things, you got the answer. That's it. This can be written as 2.303 times log of 100 on K. This is equal to, log of 100 is 2. Log of 10 is 1. Log of 100 is 2. Because this can be written as 10 to the power 2. So this is 2 into 2.303 by K. And this is simply equal to 2.303 by K. Proved. Rishikant, but in board, this is the kind of questions you will get. These are all board previous year questions. So since this is not a JEE class, this is a board level class, these are the kind of questions we will do. Devi Rajnikant, they will always give you the value of the log. So you don't need to worry about that part. If you have log involved inside the question, they will give you the value. Scar, so you can write T90% is this, T99% is this, and just write hence proved T99% is equal to 2 times T90%. That's all. Okay, that's all you got to do. Done. Okay, this is a fancy question now. What happens to the rate constant K and activation energy EA as the temperature of the chemical reaction is increased? Justify. My dear friends, from this equation, you can say that, okay, if I increase temperature, K will increase. But that is just half the explanation. Do you know where this mathematical term comes from? Do you understand where this mathematical expression is derived from? This is the mathematical expression from the Maxwell-Boltzmann's distribution. This term basically tells you about the number of particles. Just a second. Yeah. So this term essentially tells you about the fraction of particles that have more energy than the activation energy. Let me show you that analysis that we did just a little while back. The number of these particles, okay, the fraction of these particles, fraction of particles above activation energy is equal to e to the power minus EA by RT. So this expression comes from this Maxwell-Boltzmann distribution. Okay. So since we have done this explanation already, when T increases, number of molecules that already have activation energy increases, and that leads to an increase. That leads to an increase in the rate constant of the reaction. So we now understand what happens to the rate constant when the temperature is increased. What about activation energy? What about activation energy? Rate constant, you understand. What do we write about activation energy? What do you think? Nitila Darshini, you can write it in a smaller manner also. You can write this equation. You can point to this part and say fraction of particles more than activation energy. So when temperature increases, number of particles with activation energy increases, therefore K increases. If you write that much, you will get marks. What happens to the activation energy when the temperature increases? See, that is a difficult part. Generally speaking, activation energy depends very mildly on temperature. And activation energy increases mildly when temperature increases. But for Arrhenius equation, we assume the activation energy of the reaction to remain constant. Okay, so what you can write in board examinations, and this will come as a 4 or 5 mark question also, so you have to explain properly. So I'll try to write some points that you can mention. That activation energy does not vary much with temperature. For Arrhenius equation, just a second. My handwriting is as good as modern art. For Arrhenius equation, we assume activation energy to be constant for all temperatures. You can write this point. You can also write this point. You can also write at higher temperatures, since the system already is at higher energy, we have to provide it lesser external energy to activate the reaction. Since at higher energy, the system is already, at higher temperature, since the system is already at higher energy. So now we don't have to give it so much more energy. It already is at higher energy, so we will give it just a little bit more energy for the reaction to start. So if you justify with these points, you will get marks. Cool. All right. So for chemical kinetics, we have done a lot of ideas. A lot of ideas have been covered for chemical kinetics. One more thing that I want to talk about for chemical kinetics before we move on to solutions is the action of catalyst. What happens during the action of catalyst? So basically, if this is the graph of energy versus reaction coordinate, my dear friends, let's say this is the graph. Okay, this white graph is without catalyst. This is the energy of the reactant. This is the energy of the product. This is the energy of the transition state. This is the energy of the transition state. So in this particular graph, if we have to take the reactant till the transition state, this amount of energy, okay, this amount of energy is known as the activation energy. This is the activation energy. You have to give it this much energy so that the reaction can go forward. Now, the difference between the energy of the reactant and the product, this much. What is this called? This is known as the enthalpy change of the reaction. This is the delta H of the reaction. Right now, since product is at less energy than reactant, this is an exothermic process. Okay. Now, when we put catalyst, what happens is the transition state changes. The catalyst takes the reaction from a different path. So the catalyst helps it go through a different path, more like it helps it go through a shortcut. Okay. So catalyst acts like a shortcut. So what catalyst does is the catalyst will simply decrease the activation energy. So catalyst takes you through a different path and catalyst will decrease the activation energy required. So this is just some idea that I wanted to revise for you guys. And if you have time after the class, please revise from the NCERT also. See, these ideas. Transition state is also known as activated complex, just a different term for it. Fine. So, Maxwell-Boltzmann distribution is also given. But now since I've explained it to you, you'll understand this even better. You'll understand it more easily. So, if you get the time, please revise the ideas from NCERT and you can also solve the NCERT examples. That will help us a lot. Cool. So, my dear friends, as I had said, we'll do 1.5 hours for each chapter. Chemical kinetics, we've done enough practice. We've revised zero order, first order, half-life, first order, kinetics, reactions, instantaneous rate, rate dependence of each of the parts of the reaction, Arrhenius constant, Arrhenius equation, logarithmic form of Arrhenius equation. We've revised a lot of things of chemical kinetics. Cool. So now the next thing that we should do is we should move on to solutions and colligative properties. Huge round of applause to yourself for completing a revision of kinetics. Ashwin, we'll do that if we go to JEE classes. For boards, second order is not important. So, okay. Purvaja is saying zero order and first order reaction graph. Purvaja, remind me after solutions chapter is done, we'll draw the graph also. So, let's do this. Solutions and colligative properties. For 30 minutes, let's do this. Then we'll think of break. Then we'll think. Cool, yeah. In solution, should we use law? What? Scar, we'll see. We'll see. Atom 3.0 is saying, sir, finish the class ASAP. All right, people, thank you so much for watching. Bye-bye. Take care. See you tomorrow. Bro, in 1 hour, we revised chemical kinetics. How much faster do we want? What is Henry's law? What is P? Partial pressure of gas above liquid. What is KH? This is Henry's constant. And what is chi? This is the mole fraction of gas dissolved in liquid. Basically, the Henry's law says more is the pressure of gas above the liquid, more will be the amount of gas dissolved inside the liquid. It can be explained by a simple diagram like this. Scenario 1. This is the liquid. It's, let's say, a closed vessel. And on the closed vessel, you have put just one block of weight. So there are some gaseous particles over here, and some of these gaseous particles are dissolved inside the liquid. But now, in the second situation, if I increase the weight on top, if I put more weight on top, weight 1, weight 2, weight 3, I have put more pressure on top. So what will happen now is, in this liquid, I will have more gas in the liquid. So if I increase the pressure on top, more gas will be dissolved inside the liquid. Okay? So this is how we can explain the Henry's law. And before we go into the NCERT revision of this part, can you give me an application of it? Can you give me application? One simple application is cold drink. One simple application is cold drink. Cold drink is always packed, or carbonated drink I should say, is always packed at high pressure, because more pressure implies more solubility of carbon dioxide inside your cold drink. That can be one application. The other application is your scuba divers. Deep sea diving. So all those ideas you can give as the examples. Hold on, let me just open up the NCERT ones of solutions and colligative properties. So this is your Henry's law. Same example that we drew. And the law states that at constant temperature, please write the constant temperature part also. At constant temperature, the solubility of a gas in liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. Yes. In mathematics, it is written as the mole fraction of gas in the solution is proportional to the partial pressure of gas over the solution. P equal to KH into X. Okay. Very, very nice. Now the question is, how does the Henry's constant differ with temperature? How does the Henry's constant differ with temperature? My dear friends, what happens to the solubility of a gas if I increase the temperature? Temperature increases. So solubility of gas decreases. Do you want to know why this happens? When we dissolve solid in liquid, life is different. When we dissolve solid in liquid, high temperature means high solubility of solid. That is different. But when we dissolve gas in liquid, if we increase the temperature, solubility decreases. Do you want to know why? Do you want to know why? People, those who want to go to 𝐕 go to 𝐕. Those who want to stay here, stay here. Your wish. Do you know why this happens? Okay. Let me explain this to you. When a gas goes inside a liquid phase, when gas goes inside liquid phase, can I say that the entropy of the system is decreasing? Yes or no? When gas goes inside liquid, the entropy of the system decreases because gas earlier was roaming around. I know I look funny. Gas earlier was roaming around. But then that gas comes inside liquid. Now it can't roam around. Now it is stuck inside the liquid. So the randomness of the gas, the entropy of the gas has now decreased. Yes? All right. So, delta G is equal to delta H minus T delta S. People, this particular term is negative. Temperature is always positive because temperature in chemical equations has to be kept in Kelvin. So temperature has to be always positive. Delta S is negative. Do you realize this entire term has to be, or I don't want to write has to be, it will be positive. Minus sign into minus sign, it will be a positive value. If this is a positive value, do you understand, for the solution of gas, delta H has to be negative. Process will happen only when delta G is negative. Yeah. Process is spontaneous, or I can say process will happen only when delta G is negative. So delta H minus T delta S, this term is positive. So delta H first of all has to be negative. The gas will dissolve in liquid only if it's an exothermic process, number one. Number two, if I decrease the temperature, this term becomes smaller. This positive signed term should be smaller, no? For delta G to be more negative. So, to make this term smaller, I need lower temperature. Smaller at lower temperature. That is why for a gas, because of its entropy change, lower temperatures are better for solution. Okay? All right. So, what is Henry's law? We've given an application of it. We've understood that temperature increases, so solubility of the gas decreases. So, my dear friends, over here for Henry's law, do you understand when temperature increases, the value of the Henry's constant will also increase? Can you think about this idea? From here, can I say that if Henry's constant is more, solubility will be less? X is what? Or this chi is what? Mole fraction, solubility. So if I have high Henry constant, solubility will be less. At high temperature, solubility is less. So at high temperature, Henry constant increases. Low Henry constant equals more solubility. Okay, and my dear 10th class students, this class is only for 12th class students. So in case you want to go join V quiz, dance around, have some cold drink, chill, slap each other, sleep, you are free to do that. 12th class students can sit here and watch the class. Right? And if you want to go to Kaun Banega Crorepati to do the quiz, go for it. And I hope the 12th class students over here are not as childish. So I hope the 12th class students are fine with not having a V quiz. Hopefully. I don't know. I don't know what you fancy in life. Yeah. So have a look at this, people. Look at the solubility for nitrogen. When the temperature is increased, the Henry constant increases. So this proves experimentally it proves the fact that increase in temperature decreases the solubility. Yeah. Coolio. And by the way, YouTube allows 2 or 3 live streams at the same time on the same channel. So your V quiz will happen when it happens. My class will not affect it. So it's okay. Don't worry, people. Yeah. That V quiz is not starting. That is not my mistake. Okay. Cool. So have a look. People, do you realize CO2 is a non-polar gas, no? Or if you look at hydrogen, nitrogen, non-polar gas, look at the value of their Henry's constant. But when we look at something like formaldehyde, formaldehyde is a polar molecule, no? Formaldehyde is a polar molecule, small molecule. Look at how high its solubility is. 10 to the power minus 5. Lower Henry means higher solubility. So, for formaldehyde, for a polar molecule, look at how high the solubility is in water. But for a non-polar molecule, argon, solubility is so less. Anyway, so that was about Henry's law. All the best. Next question. Already know the answer. Value of Henry's constant KH increases with increase in temperature. Perfecto. Let's go to Raoult's law now. Let's go to Raoult's law. So what happens in Raoult's law, people? A, B, A plus B. So Raoult's law says that if initially we have a volatile liquid A, which will have some gaseous particles on the top, and the vapor pressure of A equals P naught A. For B, it is a volatile liquid. Volatile means easily evaporates. So if it easily evaporates, it exists in the gaseous phase also. P naught B. Now when we mix these two together, you have some B in the liquid phase, you have some A in the liquid phase, and obviously both of them being volatile will also be in the gaseous phase. Fine. So now over here I can write that the total pressure, what is this? Vapor pressure, the pressure in the vapor phase, P total, is equal to P naught A into mole fraction of A inside the liquid. Over here mole fraction of A is chi A plus P naught B and multiplied by mole fraction of B inside the liquid. So P naught is the original vapor pressure of individual liquid, and mole fraction of A in liquid is chi A, mole fraction of B in liquid is chi B. Okay, so now what does this say? Vapor pressure of pure liquid X and pure liquid Y, P naught X is equal to 120 millimeters, P naught of Y is equal to 160 millimeters. Equal mole of X and Y are mixed. So what can I say? Mole fraction of X will be equal to 0.5. Half is X, no? So 0.5. Mole fraction of Y is also 0.5. So my dear friends, final P total is equal to 0.5 into 120 plus 0.5 into 160. How much is this? Done. Coolio. So Raoult's law, derivation. Not derivation, I mean it's revised. Angel, we'll organize classes for 11th class also. What type of deviation from Raoult's law is shown by a mixture of ethanol and acetone? Give a reason. Nanatsu, now you won't hopefully forget the units because I have been telling you not to forget the units. Ethanol and acetone. It's a tricky, this is a tricky case. Some are saying positive, some are saying negative. Let's think about ethanol. What is ethanol? This type of a species. When ethanol is alone, it has hydrogen bonding. So I can say when ethanol is alone, it has decent intermolecular hydrogen bonding. But now what we are doing? Now we are putting ethanol into acetone. So this ethanol guy with acetone guy, yeah, this is acetone. Ethanol, acetone. So now the problem is this is very well networked. But when you put it in acetone over here, ethanol's network of hydrogen bonding is disturbed. Ethanol's network of hydrogen bonding is disturbed. So you can very well imagine that ethanol hates acetone. Okay, ethanol is like acetone, I do not want you, sorry. So what will happen? If you mix two things together, if they like each other, they will stay inside the liquid. Vapor phase will become lesser. If you mix two things and they like each other, vapor pressure will decrease. Two things like each other, negative deviation. Over here, what is happening? You mix two things, they hate each other. They all want to go in vapor. More vapor pressure. Because they hate each other, positive deviation from Raoult's law. So when two things love each other, negative deviation from Raoult's law. When two things hate each other, positive deviation from Raoult's law. Katie, now do you understand? So if we look at a handful of examples, you will understand this idea even better. Let's see. A mixture of chloroform and acetone forms a solution with negative deviation. Negative deviation means vapor pressure is negative, vapor pressure is lesser. So they should love each other. How do they love each other? By making this new hydrogen bond. The chloroform's hydrogen forms a good hydrogen bond with the oxygen of acetone. So because of this affinity towards each other, we observe a negative deviation from Raoult's law. Bharadwaj has been asking continuously, how many hour session is this? Bro, I have planned this session for 726 hours. So 726 hours, you will be able to give next year board examination perfect. So since 1.5 hour is already done, 724.5 hours are remaining, bro. Cool. Anyway, so this is the idea of deviation from Raoult's law. If you want me to show you more examples, I will. Let me show you some more examples of the Raoult's law as well. Just give me a moment. Yeah. There we go. So these are all the solutions that hate each other. Acetone and carbon disulfide, when you add them together, they hate each other. So you can write these examples down if you want. Okay. You can write these examples down if you want. Okay. So acetone is a polar molecule and carbon disulfide is a perfectly non-polar molecule. So they hate each other. Acetone and benzene, they are also not very fond of each other, yeah, because non-polar, polar. Ethanol and water, acetone and ethanol, this one we've understood. Ethanol and water, again they hate each other. Why? Because water's hydrogen bonding is disturbed by ethanol. So water's good hydrogen bonding network is disturbed by ethanol. So they also hate each other. So in case you want to keep these examples with you, you can, and they will be asked in your board examination, JEE examinations also. So these are some examples of positive deviation and these are some examples of negative deviation. So in all these cases, they like each other. They are attracted towards each other. Acid plus water. Acid and water, they quickly do a reaction, right? Chemical reaction. Chloride will become solvated by water. So acid plus water, or if you have, base plus water also will give you negative deviation. Benzene plus CHCl3. Chlorine, chlorine, chlorine. This is your benzene ring. So the pi electrons of benzene now start attracting the hydrogen. So pi electrons of benzene and the hydrogen of chloroform, they attract each other. Then you have all the hydrogen bonding cases. All these cases will give you hydrogen bonding together. This RCOH plus pyridine can be thought of as an acid-base case also. So these are some examples. You can refer to them later if you want. Okay. Next, board level question. Aquatic animals are more comfortable in cold water in comparison to warm water. Now we understand, because at lower temperature, more oxygen is dissolved inside water. Yeah, at lower temperature, more oxygen is dissolved inside water, so they can breathe well. This is why global warming is bad for aquatic life also. Because aquatic life is, they survive better at colder temperatures. Cold water is better for aquatic life. Do you know in the last 10 years or so, in the last 10 years or so, because of our human activities, we have killed more than 60% aquatic life. More than 60% aquatic life was killed in the last decade because of humans. Okay, next. Sprinkling of salt helps in clearing the snow-covered roads in hilly areas. Why does this happen, people? Sprinkling of salt helps in clearing the snow-covered roads in hilly areas. My dear friends, This comes from the idea behind depression in freezing point. Okay. So usually water freezes at 0 degrees Celsius. Let's say, assume outside temperature is equal to -1 degree Celsius. Outside temperature, let's say, is -1 degree Celsius, cold area. So if outside temperature is -1 degree Celsius, water will be frozen. There will be ice on the road. Now, when we add salt, freezing point of water becomes lower. Yeah, freezing point of water becomes lower. Let us say -4 degrees Celsius. So earlier water used to freeze at 0 degrees Celsius, but now water freezes at -4. So at -1 degree Celsius, it will exist as liquid. And that is why sprinkling of salt helps clear the snow-covered roads in hilly areas, because the freezing point goes down. All right. That's why the freezing point goes down. All right. Let's try this one. A compound goes complete tetramerization in an organic solvent. What is the Van't Hoff factor? How do we define Van't Hoff factor, people? What is the definition of the Van't Hoff factor? Van't Hoff factor is defined by final number of particles in solution divided by initial number of particles given. So initially, if I take 10 particles and in solution they become only 5 particles by sticking to each other, what will happen? Van't Hoff factor will become half. If initially I take 1 particle NaCl, if I put it in water, it breaks into 2 particles, Na positive, Cl negative. So now the Van't Hoff factor is 2. So final particles upon initial particles. So tetramerization means 4 particles combine to make 1 particle. So this will become 1 by 4, 0.25. Alrighty. So final particles upon initial particles is basically your Van't Hoff factor. So the same idea over here goes for NaCl solution. Why is the boiling point of 1 molar NaCl solution more than that of 1 molar glucose solution? Yeah, because non-volatile impurity increases boiling point of water. 1 molar NaCl breaks into Na positive and Cl negative, right? So because it breaks into 2 particles, there are more particles that are increasing the boiling point of water. More particles increasing boiling point of water. This increasing boiling point of water, this is basically a colligative property. People, can you define what is colligative property? If they ask in board exam, define colligative property, give an example. What's the meaning of colligative property? Colligative property is a property that depends only on the number of substances, not the nature of substance. Yeah. So colligative property is a property that depends only on the number of substances, not on the nature of substance. So more number of particles implies higher is the property. Depend on the number of solute particles irrespective of their nature. Okay. So this is the definition of a colligative property. Very nice. Next question. Mathematical question. A non-volatile solute X, molar mass 50, when dissolved in 78 grams of benzene, reduced its vapor pressure to 90%. Calculate the mass of X dissolved inside the solution. You can either do formula or you can do logic. Non-volatile solute X, molar mass 50, when dissolved in 78 grams of benzene, reduced its vapor pressure to 90%. Calculate the mass of X dissolved inside the solution. Wait, I need to give you the value of the... One second, that value is missing, no? Yeah, people? Acha, vapor pressure. Sorry, there's no value that's missing. My bad. So, for relative lowering of vapor pressure, what can I say? Relative lowering of vapor pressure. I can say delta P by P initial is equal to mole fraction of the impurity. This is what I can say. So delta P is the change in pressure, P is the original pressure, and that is the mole fraction of the impurity. So what has happened over here? P new is equal to 90% of P initial. So can I say delta P is equal to just 10% of P initial? Yeah. Delta P is 10% of P initial, or I can say 0.1 times P initial. This is the change in pressure. So over here I can put 0.1 times P initial upon P initial is equal to mole fraction. Mole fraction is equal to 0.1. So what is mole fraction of any component N? Mole fraction of any component, let's call it I, is equal to moles of I upon total number of moles. Cool. So this is all you have to do now. Molar mass is 50 gram per mole. Very nice. Molar mass is also given. So this can be written as, we have to divide. So x upon 50 divided by x by 50 plus 78 grams of benzene. 78 grams of benzene is what? 1 mole? 78 grams of benzene is 1 mole. So this is the moles of particle that is dissolved. How did I come to x by 50? Let me tell you. Mass of x is equal to, let's say, x. Molar mass is given as 50. So moles are equal to given weight upon molar weight, that is x by 50. Yeah. So this entire thing, as you can see, is equal to 0.1. Now you can do the calculation. Okay. Now you can do the calculation. Fine. So what is the mass of X dissolved in grams? Can you tell what is the mass of X dissolved in grams? Did anyone calculate? 5.5 you are saying? Cool. If you say 5.5 grams, I accept. All right. So this is the formula that you need to keep in your mind. That's all. Everything else is simple. Delta P by P is equal to the mole fraction of the impurity dissolved. That's all that matters. Let's do this. Calculate the boiling point elevation for a solution prepared by adding 10 grams of MgCl2 to 200 grams of water, assuming MgCl2 is completely dissociated. People, what can I say? Delta T is equal to Van Hoff factor into the ebullioscopic constant into molality. Yeah. So in this particular question, complete dissociation of MgCl2, it will give 3 particles, one Mg2 positive and 2 Cl negatives. So Van Hoff factor will be 3. Ebullioscopic constant is given as 0.512 kilogram per mole into Kelvin. And what is the molality? We have to calculate molality. For molality, what can we do? It says n grams of MgCl2 in 200 grams of H2O. If I multiply with 5 on both sides, what will happen? I can say I have 50 grams of MgCl2 in 1 kilogram of water. Can I say this? Now, what is molality? Yeah. What is molality? Molality is moles of solute in 1 kilogram of solvent. Moles of solute per kilogram of solvent. So we got 1 kilogram of solvent on the right hand side. We just have to convert 50 grams into moles. So molality will be equal to 50 divided by 95. So over here delta T will come out to be 3 into 0.512 into 50 by 95 Kelvin. What is delta T? How much is it coming out to be? Rabia, when did you join the class? Why are you so tired in just 1.5 hours? Your board exam is 3 hours, my friend. 3 into 0.512. How much is it coming out to be? Approximately 0.81 Kelvin. Yes? We got this? Please do the calculation on your own once. Check if you have any doubts, you can ask me. So Scar is asking, how is the Van Hoff factor 3? I will tell you. Because MgCl2 will break apart into Mg2 positive plus 2 times Cl negative. So 1 particle gives me 3 particles. 1 plus 2 is 3. So since 1 particle is giving me 3 particles, Van Hoff factor is 3. Got it? Cool, very nice. Next question. Molality part is confusing. Adil, tell me why it is confusing. What is the confusion? They gave 10 gram magnesium chloride in 200 grams of water. If I multiply it with 5 on both sides, I will get 50 gram MgCl2 in 1000 grams of water. 1000 gram of water can be written as 1 kilogram of water. Now, moles of solute in 1 kilogram of water is molality. So just convert mass to moles. Given weight, that is 50, divided by molar weight, that is 95. Okay. Cool. Let's do another question. So, see, the more we practice these ideas, we'll get better at them. Sumit is saying, can you explain how we get 10% pressure? Okay, we'll go back to that part. Doubt solving is important, so we'll do that. Where is it? Yeah. So what is it saying? When we put the impurity, the pressure was reduced to 90%. So new pressure is 90% of original pressure. That is what the question says. Yeah. So change in pressure will be equal to, this will be equal to initial pressure minus 90% of initial pressure. So change in pressure, delta P, is initial pressure minus 90% of initial pressure, which is 10% of initial pressure. Okay, fine. All right. Why is the value of Hoff factor for ethanoic acid in benzene close to 0.5? What did I say, people? What is Hoff factor? Hoff factor is final number of particles divided by initial number of particles. Yes, this is what we define Hoff factor as. Now, what happens is that ethanoic acid dimerizes in non-polar solvents. Okay, so what will happen is that two molecules of ethanoic acid will dimerize with each other. Let me show you how that will happen. These will attract each other in this manner. This is the dimer of CH3COOH. So what will happen? If I put two particles of ethanoic acid inside water, they will create one final particle. So my Hoff factor will become 1/2. So the reason that we will give over here is that ethanoic acid dimerizes in non-polar solvents. Benzene is a non-polar solvent. So this is what ethanoic acid looks like finally. Since two particles of ethanoic acid form one particle inside benzene, Hoff factor will be equal to 1/2. Okay. Sabaresh, that depends on the person who's checking your exam, bro. Sometimes they do, sometimes they don't. That is a subjective problem with board examination. Sridhar, you can ask the doubts. Shashwin, yeah, you can say that. Absolutely correct. Okay, let's do this one. Determine the osmotic pressure of a solution prepared by dissolving 2.32 into 10 to the power minus 2 grams of K2SO4 in 2 liter solution at 25 degrees Celsius. Assume that K2SO4 is completely dissociated. My dear friends, how do we define osmotic pressure? Osmotic pressure pi is equal to CRT. So this pi is your osmotic pressure. C is molarity. R is your universal gas constant, obviously. And T is temperature in Kelvin. Right? So over here it says we have dissolved 2.32 into 10 to the power minus 2 grams of K2SO4 in 2 liter of solution. So let's try to convert that into molarity. 2.32 into 10 to the power minus 2 gram solute in 2 liter solution. Let's divide by 2 on both sides. I can say 2.32 by 2 to 10 to the power minus 2 grams of solute in 1 liter of solution. My dear friends, how do we define molarity? How do we define molarity? Molarity is defined as moles of solute in a liter of solution. Number of moles of solute in 1 liter of solution is molarity. This is the grams of solute in 1 liter solution. Let's convert grams to moles. So molarity will come out to be 2.32 into 10 to the power minus 2 on 2 divided by, what's the weight for K2SO4? 174. So this is my molarity. Now just plug in the values. Achha, are we doing dissociation? Okay, we are doing dissociation also. So since we are considering dissociation, we have to keep in mind the Van 't Hoff factor. Okay, so K2SO4 will break apart into 2 times K positive plus SO4 2 negative. This SO4 2 negative is one molecule. So Van 't Hoff factor is 3 by 1. Final number of particles are 3. Initial particle is 1. So Van 't Hoff factor will come out to be 3. So this is equal to 3 into 2.32 by 2 to 10 to the power minus 2 divided by 174 into liter ATM. Please use the value that is given. Yeah, this is the value of R we use when we are doing calculation in liter ATM. So 0.082, the temperature is given as 25 degrees Celsius. So that is 298 Kelvin. This is what we have to calculate. Yeah, this will be your osmotic pressure in atmospheres. Why atmospheres? Because we are using liter ATM, right? So ATM will remain. Please do the calculation. Sridhar, can you please rewind a little and check that out? Kavya, if you don't want to attend this class, then don't attend this class, okay? Sashwin, yes, they usually give you the value of R in board examination. This is a previous year board CBSE question directly. So they will give you the value. Can you calculate what's the final answer coming out to be, people? It's an elaborate calculation. Those of you who are serious in the class, please do the calculation. Please ignore the random humans in the chats, assuming they are humans. Kishore, because pi is equal to ICRT, that's all. Van 't Hoff factor has to be multiplied in all the calculations of colligative properties, right? That's why. Julio? Got the answer? It will be 4.8 into 10 to the power minus 3. Yeah, Kichu, very nice. Those of you who are getting this, very good job. Cool. So that's the osmotic pressure of this solution. Calculation, yeah, I know, it's a little tricky. The calculation is a little elaborate. I understand. Ragul, no, you shouldn't. Temperature always has to be taken in Kelvin, okay? Purvaja, temperature in Kelvin is equal to temperature in degrees Celsius plus 273. All right. Okay, next. When 25.6 grams of sulfur was dissolved in 1000 grams of benzene, the freezing point was lowered by 0.512 Kelvin. Calculate the formula of sulfur. So this is for, this is for what? You have to calculate the Hoff factor basically. Cyrime, I've already done that, no? I've done 2 times the explanation of deriving Hoff factor. Final number of particles by initial number of particles. Please rewind and check it out. Yeah. Ritik Balaji, bro, that's a very basic mathematical thing that you should know how to do. If you're in 12th class, then you should already know. If you're in 10th class, you learn some other day. Okay. Explain wave, yes bro, these are all previous year questions of boards. So the class is for 12th class board students. For those it is helpful. So people, let's figure this out. When 25.6 grams of sulfur were dissolved in 1000 grams of benzene, the freezing point was lowered by 0.512 Kelvin. Calculate the formula of sulfur. Yes. So what will we do over here? Once again, what we do over here is your delta T is equal to I into molality into the cryoscopic constant. So I is something that we have to figure out. Molality we can calculate from the given data, and the cryoscopic constant is given as 0.512. This is, I don't know. Delta T is given as, delta T is given as 0.512 and Kf is given as 5.12. So let's figure out the molality by the given data, and then we can figure out the Hoff factor also. That will tell us how the sulfur's molecule is composed, right? So first of all, people, we have 25.6 grams of solute in 1 kilogram of solvent. As I explained a couple of questions back, what is molality? Molality is moles of solute in kilograms of solvent. We already have 1 kilogram on the right hand side. So all we need to do is convert this into moles. So molality will be equal to 25.6 divided by 32. This is the molality. So now it's just about simple calculation. 0.512 is equal to I into 25.6 by 32 into 5.12. Can you do the calculation, people? I is equal to 32 by 25.6 into 0.512 divided by 5.12. 32 by 256. 1 by 8. Hoff factor is 1 by 8. So what this means is, that 8 particles of sulfur combine together to make 1 particle. That's the meaning, right? Final number of particles upon initial number of particles. So final particle is 1, initial particle is 8. So 8 particles sulfur combine together to form 1 particle. So the formula of sulfur should be S8. Okay. The formula of sulfur should be S8. Very nice. This is a beautiful question. It's a long question, but a beautiful question. Do you want to do this now or do you want to do this after break? Adil, cool. People who are asking about how to find Van't Hoff factor, people, can you please rewind the class and see this question? Van't Hoff factor is final number of particles divided by initial number of particles, and we've done 3-4 examples of this. Please rewind and watch. Achha, most people want to do now, so let's do it now only. Yeah. After solutions and colligative properties is done, then we'll take a break. So this was asked in boards. If it is an NCERT question, okay, fine, but this was asked in board examination. When 19.5 grams of fluoroacetic acid was dissolved in 500 grams of water, the depression in freezing point is observed to be 1 degree Celsius. Calculate the degree of dissociation of FCH2COOH. So, over here, cryoscopic constant for water is given. First of all, let us calculate the Van't Hoff factor. Then we will try to see the relationship between Van't Hoff factor and degree of dissociation. So please pay attention. First of all, let's calculate molality. So I can say that your delta T is equal to Van't Hoff factor, molality, cryoscopic constant. So Van't Hoff factor is something that we need to calculate. Molality we can do over there. Cryoscopic constant 1.86, and this delta T is given as how much? Depression is 1. Achha, people, listen to me. If temperature decreases by 1 degree Celsius, can I also say temperature decreases by 1 Kelvin? If I can say something about temperature decrease in Celsius, the same temperature decrease will be in Kelvin, because the distance of unit is the same. So decrease by 1 degree Celsius is equal to decrease by 1 Kelvin. So that's why delta T can straight away be written as 1 over here. Okay. Now, 19.5 gram of solute is there in 500 grams of water. So, using the same pattern now that we've done in the earlier two questions, can we convert this to molality? Multiply with 2 on both sides. Yeah. So 2 into 19.5 grams of solute, which is how much? 39. 39 grams of solute is present in 1 kilograms of water. So, right hand side is the equation for molality. Left hand side we need to convert this to moles. So I can say molality is equal to 2 into 19.5, that is 39, divided by 78. Half. Molality is 0.5. Cool. So I can write 1 is equal to I into 0.5 into 1.86. So I is equal to 1 by 0.5 to 1.86. People, how much does this come out to be? Can you tell Van't Hoff factor? Very nice. Basically 2 by 1.86, right? So I can write Van't Hoff factor is 1.075. Okay. Now, my dear friends, listen to this part of the explanation very carefully. What we have as the solute over here, it is a weak acid. Now, weak acid will establish an equilibrium. Okay. Weak acid will be, the equilibrium will be established over here. So, HA breaks apart into A negative plus H positive. Raoult, temperature should be in Kelvin, but over here it is given decrease by 1 degree Celsius. So decrease by 1 degree Celsius is equal to decrease by 1 Kelvin. Yeah. Okay. So HA breaks apart into A negative plus H positive. So basically I'm removing this H positive and rest of the entire molecule I'm writing as A. So now to calculate Van't Hoff factor, listen what you have to do. Initially, let us assume HA is one particle. Finally, what will happen? This will become 1 minus alpha. If alpha particles react, alpha particles of product will be formed. If alpha particles react, alpha particles of product will be formed. So finally, how many number of particles do I have? Finally, I have 1 minus alpha plus alpha plus alpha, that is equal to 1 plus alpha number of particles. Initially, if I have one particle, finally, I'll have 1 plus alpha number of particles. So, people, this 1.075 is equal to 1 plus alpha. Can I say alpha is equal to 0.75? Sorry, 0.075. This alpha is equal to 0.075. That is your degree of dissociation. Okay, so this alpha is your degree of dissociation. So if you do not remember what is degree of dissociation, let me explain to you. Because generally, degree of dissociation is slightly confusing topic for most students. So let me tell you what is degree of dissociation. Okay, degree of dissociation is the fraction of initial particles that have gone to make product. It's the fraction of initial molecules that have reacted already. Okay, let us say you have 100 apples. Okay, imagine you have 100 apples. Now you eat 10 apples. You had 100 apples, you eat 10 apples. Can I say you have consumed 10% of apples? Can I say you have consumed 10% of apples? So this 10% is the degree of dissociation. Fine. So if you had 100 apples in the beginning, 10% are consumed, 10% is the degree of dissociation. Okay. So if you have 100 apples initially and you consume, let's say, 20% of them, you remain with 80 apples. Okay, fine. This 20%, can I also say you have consumed 0.2 of the initial apples? Instead of saying 20% initial apples are consumed, can I say 0.2 into initial apples are consumed? Yes. 100 into 0.2 is equal to 20. So degree of dissociation is represented as this fraction of initial particles. Degree of dissociation is not generally represented as percentage. Degree of dissociation is generally represented as fraction. So over here what has happened? Over here what has happened is that 0.075 of initial particles have undergone the reaction. So final particles are equal to 1 plus alpha in this particular case. Let's do another question. Okay, this is done anyway. There was one more question. Where is it? There was a... Okay, well, in boards you won't have any more difficult questions though. degree of dissociation is calculated. Is there anything else that has to be calculated over here? Not really. Cool. Done. In board exams, it won't be very difficult. For JEE, we'll do even more complicated questions of that part. So if you have any doubts in solutions and colligative properties, please tell me. Then we will move on to electrochemistry. Okay. So let me write over here that up next, we've got electrochemistry. A lot of practice for solutions and colligative properties is done. And do you see how different my perspective is towards physical chemistry? I'm sure the people who are here to seriously study for board examinations, you have practiced physical chemistry on your own earlier. But do you realize how different our perspective is now? We go via very basic logic instead of going through formulae. Yeah. So I hope this idea that I have shared with you of looking at things from a different angle will be helpful for your physical chemistry. Alright. Now, if you have any doubts in solutions on colligative properties, please ask me. Sir, can you show how we get the value of degree of association same like this when they give dimer or something else? So, Hari, simply imagine how many particles are making the final particle. Yeah, like we said in the case of ethanoic acid or the tetramerization case. So always think Van't-Hoff factor as final particles upon initial particles. So if 8 particles are combining to become 1 particle, Van't-Hoff factor will be 1 by 8. Okay. Hand of God, I don't expect chemistry to be difficult. Osmosis and in blood cell, please tell. Okay. No, so that's good, man. Hari, we have done 2-3 questions already on that, bro. If you came late, please watch those questions. This one we've done. We've done, where is it? This particular question. Yeah. And we've done the cases of dissociation also. So if you joined late, please rewind a little and see those examples, bro. Kichu, yeah, we'll do the break part also, man. Preeta, we've covered DNF block day before yesterday. Mahalakshmi, 1.5 hours more. Chemical kinetics is already covered, James. We did it in the beginning of the session. And next we'll do electrochemistry. Yes, Purvaja, graph, I will tell you. Good to see that there are students who are seriously attending the session. Okay, so graphs for first order and zero order reaction. So this is the first order equation. Yeah, ln of A final can be written as minus KT plus ln of A initial. Yeah, that's how I can write that graph. I mean that equation. So if I want to make the graph for ln of A at any time versus T, this will be a straight line with the slope minus K. Yeah, basically we are trying to compare this equation to y equals to mx plus c. So the intercept over here, yeah, this intercept over here will be ln of the initial amount of A that we had. So at any time A is equal to this particular graph. And if we were to convert this graph into a logarithm, I mean into an exponential graph, yeah. So what we can do is we can take e to the power on both sides. So I can write that e to the power A, sorry, if I do e to the power on both sides, this will come out of the log. So I can say that A final upon A initial is equal to e to the power minus KT. So I can write A final is equal to A initial into e to the power minus KT. So if I have to write the concentration of A at any time, which is A final, it starts from A initial and it decays exponentially like this, but never going to zero. It will only become an asymptotal graph. Okay. So this is basically an exponential decay graph. So these are the graphs for the first order reactions. On y-axis we have ln A, over here we simply have A. Alright, so this is your first order graph. For zeroth order it will be even more simple because we need to make only one graph. Yeah. So what's happening over here? A final is equal to minus KT plus A initial. For making the straight line equation, I can do this. So that's all. A versus T will be a straight line graph and the slope will be minus K. Okay. Aslam, what should be 0 for both, bro? This is the remaining concentration. Raj, so this is A final is the remaining concentration. So this A is the remaining concentration. So initially you start with this concentration. After let's say T equal to this much, only this much concentration will remain. Okay. Rishi, so practically speaking, what happens is in any reaction, it never goes to completion. Any reaction, it reaches equilibrium and stays there. So zero order graph, theoretically you can cross it from x-axis. This one you can cross it to x-axis, but practically the reaction will end somewhere over here and equilibrium will be established. So that's the reason for zero order. For first order, the mathematics of the graph do not allow. So this particular graph that you have, e to the power minus x graph, e to the power minus x graph only tends to 0 at infinity. It never reaches 0 at infinity. So first order reactions are never completed. First order reactions are never fully completed. Sorry, Preeta is saying energy profile diagram for rate determining step. Okay, so basically if you have a two-step reaction, Preeta, tell me if this is what you're asking for. If we have a two-step reaction, yeah, reactant, product, transition state 1, transition state 2, this is the intermediate. Yeah. So the step that has higher activation energy will be the rate determining step. So the first step over here is the rate determining step. That's how it works. The concentration will never be 0. Sashwin, yeah, that's correct. Half-life graph. See, bro, the thing is, you don't need a graph for half-life because for first order, the half-life is just a constant value. Yeah, for first order reactions, if you look over here, where is half-life? Yeah, this half-life is just one constant value. Okay, so there is no graph for half-life that we need to make. And for zeroth order reaction, if you calculate the half-life, zeroth order reaction half-life will be K by 2 times A, something like that. So you don't need to worry about the half-life graph. Rajmanikam, concentration remaining. Alright, so these were some ideas that I had promised you that I will revise for you, which we have done. People who have joined the class late, please watch it from the beginning. So as I told you, chemical kinetics we have done revising. Solutions colligative properties we are done revising. If you need osmosis explanation, we'll do it at the end of the session. Okay, after electrochemistry is done, if you need osmosis and all, we can revise that part also. So up next we have electrochemistry. Since we have been continuously studying in this class for 2 hours or something, let's take a small break. Because I need to drink some coffee and come back. Okay, so let us take a small little break and then I will resume with electrochemistry. So until that time, you can listen to that only song that I have for you. All right, people. What's up? All good? All spot. One more hour, perhaps. 1.5 hours maximum. What's going on in life, people? Let's do a small chit chat for a couple of minutes and then we will resume with the electrochemistry part of this session. Nitala Darshini, they might ask one or two questions. So we saw the question that said, why do they sprinkle salt in hilly areas? That kind of question might be asked where you have to explain the nature of the colligative property behind it. Yeah. So Mohan Raj is asking, expected tough level of chemistry? Not really. And the thing is that in physical chemistry, they would ask more numericals. There might be 2 or 3 explanation based questions, but mostly they would ask numericals because there's no other place to ask numericals in chemistry. Yeah. Aesthetic Abhinay, thank you so much. A username is unknown. Wow. Sir, how do I learn conversions? We have done a quite an extensive class of organic chemistry, so I suggest you have a look at that. Adi, I don't know for sure how it's going to be, but chemistry generally is on the easier side. Nitla Darshini, basically I am from Patiala, Punjab. Vidya Lakshmi, where is Shimon sir? Shimon sir actually, I think for a couple of days he is in Bangalore, and there is a certain event that we are organizing right now called the Vidya Utsav. I'm sure you've seen the trailer of it, yeah? So I think Shimon sir is busy shooting that event at the moment. I did not go to that event because tomorrow you have your chemistry board, so I was like, sorry, I have to take a class. Shashwin, yeah, well. Adi, 50 marks should be quite easy. Mohan Raj is asking, what is Vidya Utsav? So it's basically an event where we announce what is to come for the next year. We facilitate some of the older students of Vedantu who have been in the regular batches. So it's like a ceremony. So that's how it works. Scarzi is saying, how much did you score? If you're asking my board examination marks, 93% was my overall total CBSE boards 2011. Ashwin, so you can see my classes on this channel called Catalysis by Vedantu. Over there, you will find classes of almost all the chapters of chemistry, and those are all in English. Purvaja is saying, so for biomolecules, what structures are important? Especially the structures of glucose, those cyclic structures. Those are important. Then you can keep in mind the structures of deoxyribose and ribose. And then you can also understand the basic formation of amino acids. Nishal is saying, how much in chemistry? I think 90 marks in chemistry I got, I think, in board examinations. So I got 95 something in English. I got some 95 something in physical education. I got 95 in physics. In maths, I think I had the highest, 98 or 99, because board mathematics is easy. Chemistry, I had 90 something marks. So overall, 93% was the scenario. Roshan, yeah, nucleosides and nucleotides, that's an important thing. Rajesh is saying, so please teach Vedantu J English channel regularly. We'll have a discussion with our team, and what we need to do for the next year is still not decided yet. So I might continue teaching in English on this channel for students of 11th and 12th class students. That is a discussion that's being held. I might teach on Vedantu English channel. So I'm not sure exactly how it's going to work, but you will see me around for sure. And definitely I'll be there in the regular sessions that we do at Vedantu. If you come into any course at Vedantu of 11th or 12th class, especially for JEE, I would be there. English courses, of course. Abhinay, I'm glad it helped you. in-text questions or board questions, which is important to solve at the last minute. Shri, either of them are fine, man. They're very similar questions, in fact. So, whatever catches your fancy. Adi, thank you so much for your appreciation. All right. Chalo, let us move towards electrochemistry. And the first question that we have over here, the correct cell to represent the following reaction is. So, people, how does it work in electrochemistry? Let's first understand. On the left hand side, I usually keep the anode, and on the right hand side, we usually keep the cathode. Okay. Now, always remember that in electrochemistry, no matter what your cell is, if it's an electrolytic cell, if it's a galvanic cell, if it's an electrochemical cell, whatever cell you have, in the case of anode, we will always have oxidation. Anode, always oxidation. Cathode, therefore, will have reduction. Now, one weird way to keep this in your mind is that anodes A, oxidation O, A and O, right? These both are vowels. A, E, I, O, U, vowels, right? So, anode and oxidation both start with vowels, so they are related to each other. So, on anode, always you have oxidation. On cathode, you always have reduction. So, whenever we represent a cell equation, the left side has to be the oxidation half, the right side has to be the reduction half. So, you can see that zinc is getting oxidized over here and silver is getting reduced over here. So, we would keep zinc on the left and silver on the right. Therefore, D is the correct answer. So, zinc goes towards zinc 2 positive and Ag positive goes towards Ag. Right? David, it will be another hour and a half approximately. We might finish in just one more hour. All right, next. On diluting two electrolytes A and B, the lambda molar of A increases 25 times, while that of B increases by 1.5 times. Which of the two electrolytes is strong? Justify your answer graphically. People, to understand this jazz, we need to revise some ideas about conductivity, molar conductivity, limiting molar conductivity, specific conductivity, etc., etc., all those ideas. So let's do that revision first, and after that revision we'll come back to this question. This has to come from a certain graph that is given in the NCERT. So we'll revise that graph also because graphical questions are also asked. Cool. So, my dear friends, do you remember the basic expression of Ohm's law? What is this R? This R is resistance, right? This R is resistance. Resistance is basically the friction, you can say, that electricity has to face, the resistance that the electricity faces, right? Now, my dear friends, if I take a block of 1 meter length, 1 cubic meter block, yeah, I will say that the resistance of this block is equal to resistivity. So I can say that resistance of this block is equal to resistivity. That's the first thing. And let us call this rho. Now, teaching you physics all of a sudden. Now, do you realize that resistance R is proportional to length? Because more is the length of my conductor, my electricity will face more resistance because you have to go through such a long length. So, more length, more will be the resistance. Acha, do you realize resistance is inversely proportional to area? Let's say current has to pass through this much of an area. Very small area to pass through, more resistance. Now say current has to pass through this huge area. You can pass lots of current through that area. So resistance will be inversely proportional to area. So over here I can say that resistance is equal to rho into L by A. More length, more resistance, more area, less resistance, and rho is basically the standard defined resistance of this particular block. All right. My dear friends, what is L by A? L by A is basically known as cell constant. This is known as the cell constant. This is your length L. This is your area A. That is known as cell constant. Now, if I take the inverse of this equation, what can I say? I can say 1 by R is equal to 1 by rho into 1 upon L by A. I can write A by L on that side, that's fine. But for now, I will write 1 upon L by A. Because L by A is cell constant. Okay. Now, people, this 1 by R is called conductance. 1 upon resistance is conductance. So basically resistance is the main thing, but we then convert it to conductance because for chemistry conductance makes more sense. Conductance is the ease by which the current can travel. Easier current travel implies more conductance. Okay. This is known as conductivity. This conductivity is basically the conductance of this particular block. Conductance of this block is called conductivity. In old days, this used to be called specific conductance, but that became too confusing for everyone. So they started calling it conductivity. So people, you can use different symbols for this if you want. Okay, you can use different symbols for this if you want. In different books, you have different symbols. If you want to call conductance as G, you can call this as lambda. All right. There was a lag that came. Happens sometimes. Internet disconnections. So point is, you don't need to worry too much about this equation. If you understand this jazz, that is more than enough. Okay, that's more than enough. So now let us try to come back to this particular point. Now what we have defined over here is something called lambda molar. This is known as molar conductivity. What is molar conductivity, people? Molar conductivity is defined as the conductance for solution containing 1 mole of electrolyte. Containing 1 mole of electrolyte. Now, let us try to understand this. This is a very misunderstood concept, but I will explain it to you now. People, imagine there is this particular solution and I have 1, 2, 3, 4, 5, 6, 7 ions in this. I have 7 ions over here right now. If I increase the concentration of ions, if I now increase the concentration of ions, let's say instead of 7 ions, I have many ions. More ions implies better conductance of electricity. So can I say when concentration increases, conductance increases? That is very obvious. When concentration increases, conductance increases. Acha, if I increase the concentration of ions in this particular box, if I increase the concentration of ions in that box, can I say that instead of conductance, I will simply write that conductivity increases? This is very obvious. When concentration increases, number of ions per unit volume is increasing, so there will be more conduction of electricity, so conductivity increases. This is Pretty simple. But now, yeah, I don't know why it starts lagging again and again. I'll refresh from my side. Just give me one moment. Okay. Let's hope it doesn't lag again. There's some problem with the internet, I think, in the office. Anyway, so now let us say I have a 1 molar solution. Can I say I have 1 mole of ions in 1 liter? I'll refresh again. Wait. Okay, let's see. I've decreased the bit rate of the stream. So because I've decreased the bit rate of the stream, hopefully it doesn't lag as much. Let us hope it doesn't. Even yesterday in my live session, I was facing this problem. Something happens to the internet in the evening, man. I don't know what. Okay. So that's the jazz that's going on over here. For 1 molar solution, 1 molarity, 1 mole of ions are there in 1 liter of solution. Acha. Now if I have 0.01 molar solution, when will I have 1 mole? What does this mean? This means I have 0.01 mole ion in 1 liter. Can I say I have 1 mole in 100 liters of solution? Yeah. Do you understand this jazz that I'm trying to tell you? 1 mole solution. So basically the molarity right now is 1 molar. So 1 mole ions will be there in 1 liter of solution. But if I decrease the concentration, 0.01 mole ion will be in 1 liter. So to take 1 mole of ions, I need 100 liters of solution. So my dear friends, when I decrease concentration, what happens to molar conductivity? Yeah. When I decrease the concentration, what happens to molar conductivity? On decrease in concentration, the volume required to take 1 mole ions becomes huge. Yes, the volume required to take 1 mole of ions becomes huge. So because the volume I have to take is so huge for 1 mole, this is why molar conductivity increases when concentration decreases. Okay, so when we talk about normal, usual conductivity, more concentration, more conductivity, fine. But molar conductivity is different. Molar conductivity means conductivity of 1 mole ions. If I decrease concentration, 1 mole of ions will be in 1000 liters or 100 liters. Depends on how low the concentration is. So because of that reason, to take 1 mole of ions, I need such huge volume. Molar conductivity increases with a decrease in concentration. Molar conductivity increases with dilution. Now, there is a certain variation that we follow. This one. We'll look at this graph and then go back to that original question where we started from. In a plot of lambda molar against the square root of concentration, for strong and weak electrolyte, the value of limiting molar conductivity of weak electrolyte cannot be obtained graphically. Suggest a way to obtain this value, etc., etc. So, my dear friends, when we plot the value of molar conductivity, lambda molar means molar conductivity, and on the x-axis, if I have root of C, do you realize when the concentration decreases, lambda will increase? This is what we understood. When concentration decreases, molar conductivity increases. So we can expect this type of a graph over here. Concentration decrease, lambda molar increase. Fine. So people, the interesting thing over here is, wait, I have to open the NCERT of electrochemistry. This molar conductivity part is the lengthiest part. After this, things are very simple. So, where is the molar conductivity graph? This one. KCl. What is KCl? KCl is a strong electrolyte. So for strong electrolyte, root of C varies linearly. Okay, on x-axis we have root of C. Root of C varies linearly with the molar conductivity. Okay, this is a linear graph. So we can write an equation for this. Yeah, we can write an equation for this. So if I can figure out 2 points on this particular graph, I can figure out its slope. Delta y by delta x will be the slope. And if I can figure out the slope, I can make the entire graph. Now, what is limiting molar conductivity? What is limiting molar conductivity? Limiting molar conductivity is lambda molar, but calculated at infinite dilution. Okay. What do we mean by infinite dilution? Infinite dilution means your concentration tends to 0. So when concentration tends to 0, molar conductivity should increase. So for strong electrolytes, since it is a linear function, you can simply plot the graph and calculate the value of limiting molar conductivity. This is your limiting molar conductivity. Very nice. Limiting molar conductivity. But on the other hand, for a weak electrolyte, this is not a simple graph. For a weak electrolyte, it is an exponential graph. Okay? For weak electrolyte, it is an exponential graph. So exponential graphs are very difficult to calculate. Linear graph, you can calculate 2 points, you know every point on this graph. But exponential graph, now how do I figure out? It's very difficult. So for strong electrolyte, this is the equation. Yeah. This is your normal, simple molar conductivity. This is your molar conductivity at infinite dilution is equal to minus A root C. Simple as that. This is your slope of the graph. So for strong electrolytes, very simple equation is there. For weak electrolytes, we don't have equation. What will we do for weak electrolytes? I will tell you. But first, let us go to the question that we had started from. This question. Yeah. So let's solve this question and then we'll go to the idea of limiting conductivity for weak electrolytes. We'll use Kohlrausch law. On diluting two electrolytes A and B, the lambda molar of A increases 25 times, B increases only 5 times. Which of the two electrolytes is strong? Can you tell? When we dilute, this is your strong electrolyte. The variation is very less. But what happens to weak electrolyte? Weak electrolyte changes suddenly. For this much dilution, let's say I'm going from this concentration to this concentration, this much dilution, strong electrolyte value changes just a little, weak electrolyte changes a lot. So there will be more change in weak electrolytes molar conductivity. Yeah, I can write there will be more change in molar conductivity of weak electrolyte. Strong electrolyte, just a little bit of change. Weak electrolyte, so much change for the same amount of dilution. So, since there is more change in lambda molar of weak electrolyte, A is weak electrolyte, B is strong electrolyte. So, you draw this graph, you write this statement, you write this, you will get full marks. Okay? Look at the graph. The change in the strong electrolyte is very less. The change in weak electrolyte is so much for the same change in concentration. So for the same change in concentration, change in strong electrolyte will be less. Only 1.5 time change. For weak electrolyte, you are going from this value up to this value. Lot of change. So increases more. Okay, yeah. So what was I saying? I was saying that we will come to more questions of molar conductivity. In that molar conductivity, I hope you understood what is molar conductivity, what is limiting molar conductivity, what is usual conductivity, and how it varies for strong electrolyte, weak electrolyte, what happens on dilution, all those concepts, graph, very nice. Now we'll do some more questions and then get back to molar conductivity where we'll solve more numerical questions also. Okay, chalo. This was a 4-mark question in board exam. 1 mark for every point. Very quick. Name the cell which was used in Apollo space program. Fuel cell, where we use H2 plus O2. Yeah. So I will revise all these batteries and cells for you quickly. They are given in the good old book of NCERT. Where is our electrochemistry? Yeah. So this is the example of a fuel cell. Yeah. Apollo space program. So it uses the reaction of hydrogen with oxygen to form water. And that is supposed to be an exothermic reaction, so that generates some energy for you to harness. So the cathode over here, oxygen combines with water and 4 electrons. So your oxygen basically turns into this OH negative, water turns into OH negative, and then on the other side, on the anode where the oxidation is happening, your H2 and OH negative convert to H2O. These are the kind of reactions that happen. Overall reaction is H2 plus O2 giving water. Very nice. So this fuel cell was used in the Apollo space program. Now the other part of this question says, which are the cells used in automobiles and inverters? Lead acid battery, this very simple battery that we have in our cars. Lead acid battery. Yeah. So in the lead acid battery, what do we have? In the lead acid battery, essentially we've got this type of a system. On the anode, we've got lead with sulfuric acid. On the cathode, we have lead oxide with sulfuric acid. People look at the overall reaction for once. Lead plus lead oxide going towards lead sulfate. Notice the oxidation states of lead, please. Lead over here is in the 0 oxidation state. Over here, lead is in its, what's the oxidation state of lead over here? Plus 4 oxidation state. And eventually, it is going to lead plus 2. What type of a reaction is this? Lead 0 plus lead 4 going to lead 2. This particular reaction, my dear friends, is known as comproportionation. This is the opposite of a disproportionation reaction. Remember, we studied what is disproportionation in Cannizzaro reaction. When we were doing organic chemistry, we studied Cannizzaro reaction, and that was supposed to be a disproportionation reaction. When one thing gets oxidized and reduced at the same time, that is called disproportionation. The opposite of that is known as comproportionation. Yeah. So this is a comproportionation reaction. So a lead acid battery is used in automobiles and inverters. Acha, what is used in hearing aids and watches? That small little button cell you have. So over here, we'll call this the lead acid battery. What about this one? The button cell you have, which is also known as the mercury cell. Let's have a look at what is there in the zinc mercury cell. Yeah, it's a very beautiful cell. There is something very special about that cell that we need to understand. Yeah, so this mercury cell, which is suitable for low current devices like hearing aids, watches, consists of zinc mercury amalgam as anode and a paste of HGO and carbon as the cathode. Have a look. Anode is this zinc amalgam and cathode is HGO. Now the overall reaction looks like this. Look at the overall reaction. My dear friends, do you see that in the overall reaction there is zinc amalgam, which is going to be a paste, solid HGO, solid zinc oxide and pure liquid mercury. My dear friends, do you realize that the reaction quotient of this reaction will always be 1? Do you realize? The reaction quotient will always be 1, because when we write the expression for K equilibrium or when we write the expression for reaction quotient, we take only gaseous and aqueous things. Nernst equation, we'll do that. We only take the contribution from gaseous things and aqueous things, pure solids and liquids, solid, 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 liquid. Solids and liquids do not have any contribution in your reaction quotient, and that is why the cell potential is approximately 1.35 and remains constant during its lifetime, as the overall reaction does not involve any ion inside the solution. So this is your mercury cell, which is used in hearing aids and watches. And last one, does not give a steady potential and is used in transistors. This one is your Leclanche cell. People, what is Leclanche cell? Does anyone know? Have you ever seen a Leclanche cell in life? Have you ever had the good opportunity to see a Leclanche cell? Can you tell me in the chat if you've ever seen a Leclanche cell in life? Let me check. What do you guys say? You say no, sir. Yeah, this is the problem with our education system. This is Leclanche cell. This one, our usual battery that we put in our remote control. This is Leclanche cell. Everyone has seen this. Okay. So these AA batteries, AAA batteries, they might use different electrolytes, but they are all forms of the Leclanche cell. And let me show you what one of the forms that is mentioned in the NCERT, this one, commonly used in our transistors and clocks, this one, simple. So what it has over here is zinc and manganese oxides. Okay, zinc and manganese oxide. Yeah. So as a chemist, this is what makes me sad about our education system, that the simplest of things are made complicated. This is a typical dry cell that we use every day. You can read about it later if you want. Leclanche cell. So next, using the reduction potential values of X and Y given below, predict which is better for coating the surface of iron to prevent corrosion and why. Value of Fe2 positive going towards Fe. What I want to do is, I want to stop the iron from getting corroded. What is corrosion? Corrosion is basically thought of as iron getting oxidized. Now, when iron gets oxidized, what is the voltage associated with this process, people? This is the voltage for iron getting reduced. Volts. So, my dear friends, ayyo, there is a lag. What's wrong with me? People, this internet lag is killing me. I don't know why it's happening. I got no idea what is happening. I'll say the statements again. Corrosion can be thought of as iron getting oxidized to iron 2 positive. What is the voltage associated with iron getting oxidized? What is the voltage associated with iron getting oxidized? See, this is the voltage for iron getting reduced. Yes, reduction potential is the voltage for something getting reduced. So, when iron gets reduced, the voltage is minus 0.44 volts. So, what happens to the voltage when iron gets oxidized? It becomes plus 0.44 volts. Similarly, when Y gets oxidized, reduction potential is this much, so oxidation voltage will be 0.14. Reduction is minus 2.36, so oxidation is plus 2.36. Now, people, भाई कोई स्टूडियो मैनेजर या कोई है क्या इधर? अच्छा, इंटरनेट ड्रॉप हो रहा है बार बार ना, क्यों हो रहा है? Give me 1-2 seconds. I will try to restart my streaming software at least. Okay, people, I have decreased the bitrate of the stream a little more. I have restarted my streaming software again. Let's see how it is gonna work now. And looking at the chaos that is going on in the chat box, I'm really sorry, but I have to do this. Okay. So, people, just to do you remember the idea that delta G is equal to minus NFE? Yeah. So delta G is equal to minus NFE. Can I say that higher value of potential is equal to more negative delta G? Higher value of cell potential, higher value of EMF implies more spontaneous reaction. Yes. So people, do you realize that this yeah, man, there's too much lag. 1 second, people. सर जी, इंटरनेट का कोई सिस्टम, सर जी, इंटरनेट का कोई प्रॉब्लम चल रहा है क्या? बार बार लैग आ रहा है, मतलब इंटरनेट में कुछ तो दिक्कत है क्या कहीं?
एक मिनट
चेक कर लीजिए, है ना आप। I have no idea why this lag is happening, man. Because YouTube says the streaming is healthy. We'll try once again. If it doesn't work, then we'll start a new stream. Do you understand that out of these three processes, this one is the most spontaneous? Iron is somewhere in the middle. So if I include this and this together, okay, if I do these two processes together, iron will happen, iron will get oxidized, but that is what I want to stop. More voltage means it will happen, less voltage means it will not happen. So when we compare these two processes with each other, do you understand? Iron will happen over here, this one will not happen. But when I combine iron with X, now X process is easier to do. So this process will happen, but the iron corrosion process will not happen. Okay, so this is why we should use X for coating the surface of iron. To stop iron from getting oxidized, we put X because that gets oxidized easily. So that stops the iron from getting oxidized. Yeah, Shailesh, these are previous year questions of board exams, bro. All right. Oh my god, that easy question took like 2 hours because of this lag. Write the Nernst equation for the following cell reaction and how will the E cell be affected when the concentration of ions is varied in this particular fashion. Okay, so can we figure out how this is going to work? The Nernst equation, how do we write Nernst equation? Do you remember? Okay, E cell is equal to E naught cell minus RT by NF ln of reaction quotient. This is your Nernst equation. It can be simplified in this manner. E cell is equal to E naught cell minus 0.059. People, I'll just restart the stream. This stream, I'll end the stream and I'll start a new stream. Okay, so please make sure you join from the homepage of this channel. Give me 2 minutes, I'll restart.